We are going through the topic okay, we are going through the topic of traffic data collection. Okay, and we have talked about the outcome which we are targeting from this topic. We talked about some basic concepts, then the sources of traffic data, uh, the applications of traffic data, different types of studies, and different techniques. Okay, there are three types of techniques for collecting traffic data: manual, semi-automated, fully automated. What we have covered up till now is manual. So we covered manual counting, and the most important part of that thing was how to cover for the breaks. Okay, how to cover for the breaks. So that is an important aspect for which we did this example where we converted the 12-minute count to 15-minute counts, and we also filled up the alternative breaks for each lane. It keeps on dropping, so I need to check again and again if I'm online or not. Okay. Then we moved on to speed studies. Speed studies, we have two types of errors, so we need to adjust for the errors in this case. One of them is random. So if you get enough samples, you take an average. There's no problem with that. The other one is parallax, which depends upon the position of the observer. We looked at how we can sort out this issue. Okay. Then I give you some guidelines which you need to keep in mind when you are doing the speed studies for your term project, the real one. Okay, and by the way, I will give you more details in the coming topic. So we have finished the manual techniques, okay, or the manual methodologies of traffic data collection. Now we are moving towards semi-automated studies, semi-automated methods of traffic data collection. So in manual studies, the observer has to be on the site to collect the traffic data, whether with the device or without the device. Okay, whether using a stopwatch, a speed gun, or a hand counter, these things will not collect traffic data on their own. When we talk about automated studies, we are talking about devices which can sense traffic data and record it. It could be a camera, it could be a counter, it could be a speed radar, the ones which you see for overspeeding. So you don't see any person who is pressing the button there to get your data. Okay, it works by itself. Okay. So there are two types of automated studies. We are talking about semi-automated right now. Okay. So the difference between semi-automated and fully automated is a type of device. In semi-automated, we are using portable device. Okay, the device which we are using is portable. This device, once installed on the road, can collect traffic data without you pushing or pressing anything. Okay, so after installation, you can sit back, relax, go to your office, whatever. But the device is portable. Now, who can give me the example of a portable thing? What do we mean by portable? Yes. So when we say something is portable, what do we mean? Can you give me an example of something which you have portable? Yes, anything which is portable. Phones, yes, phones are portable. Yes. Anything else? There must be more things, right? Yes. Testing equipment, like what? Portable means movable, yes. Okay. So testing equipment, if you are talking about like a The equipment which they have for sugar test and blood pressure test, yes, those are also portable. Okay, and your laptops are portable, your tablets are portable. Okay, your brains are portable, you are carrying them, right? So these are all examples of portable items. Uh, just a small clarification here. And there's something which we call as portable as well. So there is portable which with an R, and there's portable without an R. Okay, so portable is something which is we use for water, portable water. Okay, we know water is portable, we can carry it in a bottle, but the water which we are carrying may not be portable. Okay, so it's not my area, it's not part of this course, just to give you a perspective. Okay, so for semi-automated studies we use devices which you can carry, stall on the road, data, collect data by not being there. The study is done, we come back, we take out the device and bring it to the office for getting the data out of it. Okay, so you get the data of the study once you bring the device back to your office. This is what normally happens. The most commonly used type of portable device is a pneumatic road tube. Okay, pneumatic road tube. The main function of the road tube, you see, I have shown you earlier as well, so show you again. I'm not sure whether you can see it, but just to give you an idea. So you see these two black lines here. Okay, these are called pneumatic road tubes. Okay, so you just peg them on the other two sides of the road. Okay, and you just lay it out on the road. It's like very thin wire, that's it. No disturbance, nothing, no excavation needed, no difficult type of installation needed. You just peg them on the side of the road and you lay it out on the road itself. When the car passes, there's a sensor on the tube, and that sensor uh, is connected to the counter on the side. So there's a counter installed on the side of the road, and the sensor is in the tube. When the car passes, the sensor will send the signal to the counter will count it. Okay, now you can see this road tube will count when these wheels will pass over it, and then they will count when these wheels pass over it. Okay, so they will count what we call as axles. Okay, they are basically counting set of wheels, not the car itself, not the vehicle itself. Okay, the counter will give you how many times the tires passed over the tube. Okay, so they're counting the set of tires. Okay, and each set of tire is called as an axle. Okay, so the main function of these tubes is to count number of axles. If you know the distance, the normal distance between the front axle and the back axle, okay, then you can calculate the speed as well, because this distance is constant, right? And the counter is giving you the time. The first axle passed at 0 second, the second one passed after 3 seconds. Okay, so you know the distance between the axles, and you know the time, so you can calculate the speed of the vehicle as well. So this is something which you can further do. Okay, and another thing, obviously I'm not looking for counts of axles, I'm not looking for counts of tires, I'm looking for count of vehicles. Okay, so I have to do a short manual study so that I have the conversion factor to convert axles into vehicles. So I need a short manual study. That study will give me a conversion factor. So the tube will give you number of axles. The manual study will give you the conversion factor, and then use both of them to get the number of vehicles. Okay, how? Let us look at an example. So let's say pneumatic road tube was used for 24 hours. Okay, now we already said that manual studies are not done for longer times. So this is where the automated studies will come handy. Okay, so you did it, and the tube gave you a count of 11,250. Okay, the count of the tube is 11,250. Now, as I said, this is not the count of vehicles. This is the count of the set of tires, axles. So, and you will see the term actuation here, and we will use this term again in some other case as well. Actuation means the observation of the sensor. Okay, whenever you put a sensor on the road, every count of that sensor is called as an actuation, because the counting system is actuated. So that's why we call it the actuation. Okay, so basically the count. It is basically the count, but because it is done by a system, we call it actuation. Okay, so each in 24 hours we have total of 11,250 actuations. These are number of axles. I want to know number of vehicles. What will I do? On the same site, preferably during the same 24 hours, I'll do a manual study as well. In this manual study, I will have number of axles on one side and I'll put my count on the other side. So let's say I did it for 5 minutes. I did a manual study, let's say for 5 minutes. In those 5 minutes, I had some vehicles which were having 2 axles, some with 3, some with 4, some with 5, some with 6. Okay. The factor I am looking for is number of axles per vehicle. I want to calculate number of axles per vehicle so that I can convert this count into number of vehicles. Okay. So from this manual study, I will do total vehicles upon total axles. Okay, so the total vehicles we already know from this table. Okay, okay, so I was saying the total vehicles I already know from this table. 157 plus 55 plus 50 plus 33 plus 8. Okay, so this will give me the total number of vehicles. Okay, which is 303. Okay, Bayan, you are doing something which is very good for me, but I'm afraid you're in the end you may not like what will happen because of this. Okay, I appreciate it really. Okay, that you are putting up the answers, you're doing it in advance. I appreciate it. Okay, but it may uh, it may not be good for you guys. Okay. Okay, anyways, I will not open my secret, but thank you for that. Okay, so we have 303 vehicles. Okay, for the number of axles, I cannot add these axles together. Okay, because these are just numbers which I'm observing. Okay, I need number of axles in these 303 vehicles. How many axles were observed in these 303 vehicles? Okay, so I have to multiply the vehicles with their number of axles. Okay, so I got 2 axles 157 times. 2 axles 157 times, 3 axles 55 times, 4 axles 50 times, okay, and so on and so forth. So this is what we have to do. Okay, with each vehicle you multiply with the number of axles, okay, to get the number of axles for that type of vehicle. Okay, 314 axles what with 2 axle type vehicle, and 165 axles with 3 axle type vehicle, and so on and so forth. Okay, and in the end you are doing number of axles per vehicle, so you got 303 axles, 303 vehicles. Okay, and you got 892 axles. Okay, 303, 892 divided by 303. Okay, so how much is this? This is my conversion factor. Okay, this is my conversion factor. So I got 892 axles and 303 vehicles. So what is the conversion factor here? 2.94. Okay. Okay, so every vehicle has 2.94 axles on average. Okay, so what we will do now, I got number of axles from here, total 11,250. Okay, these are axles, and I know average vehicle has 2.94 axles. Okay, so 11,250 divided by 2.94. Okay, and you got what? 3821, right? Okay, this is 3821 vehicles because they said 24 hours, so I will say per day. 3821 vehicles per day. Okay, 26. Okay, 26. Okay, so now imagine if somebody is fine. Okay, you can like I said earlier, you can like fight with each other and see like who should I go with, 26 or 27. It's fine for me. Okay, but imagine if somebody did not do this manual study and he assumed that every vehicle has two axles. Okay, that all of them are cars. Okay, so if you do 11,250 by 2, how much you will get? Yes, how much if we didn't do this conversion factor? How much in that case? So now imagine 5,600 and the actual answer is 3,800. Okay, imagine the difference. Okay, it's almost the entire capacity of a lane. You are missing an entire lane here. Okay, or you are over counting an entire lane. Okay, so that's why the manual study is important. Just one thing here, the tube study was for 24 hours. The manual study, as I already gave you in the example, it could be 5 minutes, 10 minutes, because this is just to get the factor. Okay, so if you feel that I have got enough count in 5 minutes, you can stop it there for manual study. Okay, this will give you a factor which you can use with your tube study, no problem. Okay, but you should try to match the timing and the day and so on and so forth. Okay, so the pneumatic road tubes can be put in different setups depending upon what type of count you are looking for. So if I'm looking for the total count of the road, I don't care about which direction, I don't care about which lane. So I can lay out one tube from one end to the other, okay, and one counter only. Okay, so the first setup will give you the total of the entire road, but you will not know how many in each direction and how many each lane. The second setup gives you for each direction. So the tube is laid out in each direction separately, and there's a separate counter for each tube. Okay, so this will give you total for each lane, but again you will not know how much count in each lane. If you are interested in more detailed count, I want to know how much in each lane, then you will have to put the tube for each lane as well. But putting the tube for each lane is not so simple, because especially if you have a middle lane. Okay, if you have a middle lane, so you have an inside lane and an outside lane, and then you have middle lane as well. Okay, for inside lane it is easy, you can see the first. For outside lane they are doing it like this, but I can do the other way around as well. For the outside lane, if I have a median, I can do this inverse. So I will lay the tube in one lane and put the counter on the median. This can be done as well. Okay, so I'll put the tube over here and I put the sensor over here. This can be done as well. Okay, so this will also give you count for one lane, the outside lane. Okay, but they are doing it like this, no problem. But the middle lane is problematic, because your tube will go from the lane till the end for the sensor. The sensor has to be on the side, okay, side of the road. So that means I cannot have just for one lane. The middle lane cannot be done alone. So you will have the middle lane and you have the other lane which is to the side of the road. Okay, so in this case you will have the count of two lanes. Okay, so you will take the count of two lanes and subtract the count of the other lane from it. So you have to use, if in case of count required for each lane separately, you have to use the count of one counter for the count of the other counter as well. So this count will not be complete until I subtract it from the other counters. Similarly, the third one will not be complete until unless I subtract this one from it. Okay, so this will give you for two lanes, subtract one lane, you get for middle lane. This will give you three lanes, you subtract the other two lanes, you will get for the outside lane, and so on and so forth. Okay, then we have the automated studies, fully automated studies. So the previous one was semi-automated. This one is fully automated. Okay. So fully automated, we also have sensors, detectors, but they are not portable. They are not portable. Okay. So you install them permanently on the site. We are using permanent detectors, permanent on the site. Once you install them, we will not take them back to the office. We are not planning to take them back to the office. Yes, you may take them back because of repair or something, but we are not planning to. The point of the detector is that it will work 24/7 throughout the year. These permanent detectors work 24/7 throughout the year. Okay. So the counts which we get from these permanent detectors are also called as ATCs, automatic traffic counts, because we are taking them automatic and they are coming throughout the year. So we call them ATCs. So this is another name. So if you see ATC, that the ATC of this location is blah blah. Okay, that means the count is taken by a permanent detector. So the ATC is refers to the device is a permanent detector. Okay, if the device is permanently installed on the road, then you need to have some mechanism to transfer the data to the office without any deinstallation. Okay, so data has to come to me in the office real time. Okay, I will not remove the device for collecting the data like I was doing with the tube. Okay, with semi-automated, you get the data once the device is removed. In this case, no. So permanent detectors have some communication system with the traffic control office. It could be through VPN, it could be through Wi-Fi, it could be through fiber, whatever. Okay, but we need real-time access to the data. Okay, they provide real-time access to the data. Okay, so they are permanent. They work 24/7 throughout the year, and you need the real-time access to the data. Because these detectors are permanent, so companies, they design it in a way that they can give you more than one observation. So they will give you the count, and they may also give you the speed, or they may also give you the video of the road, or they also may give you the something else, signal timing or something else. Okay. So permanent detectors are usually multifunctional. Okay, they are multifunctional. Okay, this is an old book. You can find latest edition for that. Okay, because it's from FHWA. Usually, they revise the books every few years, but it's not our field. Okay, design of the detectors and devices is not our field. It comes from electronics or something. Okay, so they have mentioned different technologies which are used in these detectors. They can be sound technology used there, acoustic. So passing of the vehicle has increases the noise level. So when the noise level spikes, the detector starts counting. So this is sound technology. It can be done through opacity as well. Opacity basically means image detection. Okay, opacity means image detection. Okay, so the device is basically capturing the image. It could be pictures, image in the form of screenshots, pictures, or it could be image in the form of video. Okay, in terms of computation, we call both of them as image processing, image detection. Okay, because even from the video, the software is detecting images. So opacity means image detection. So there's some sort of a camera there. Okay, not the camera by which you will be taking videos for your term projects maybe, or then you have to do the analysis manually. We are not talking about that, because these are permanent detectors. Okay, so if you are doing that, then you are in a problem, because the data is there, but I need somebody to sit there on the PC and give me the data. Okay, so these permanent detectors, they process the image as well. So they are not normal cameras. Okay, they are cameras with processors. Okay, so they will capture the image, and then they will do the processing of the speed and the count and whatever, and then they will give you the final answer. Okay, and the image can be the simple image which you have video. It can be infrared image, it can be some other type of image as well. Then we have detectors which work on magnetic sensors. Okay, or transmitted energy like in the form of infrared or electromagnetic. These two are similar. Geomagnetism and transmitted energy. These two are similar. Okay, so you may have used the total station in surveying, right? Total station or something else. So how do they work? Total station works like you put one part of it on one point on a stand, and the other person is standing on the other side with the rod. Okay, and the total station is observing the rod, right? Okay, so these detectors work on the same principle. You have a transmitter and a receiver. Transmitter, receiver. So you put the transmitter on one end of the road, the receiver on the other end of the road. When the car passes, their signal breaks. Okay, as signal breaks, the count is being made. Okay, so this is based on, these two are based on the transmitter and receiver mechanism. Then we have electromagnetic induction. We also call them loop detectors. They are installed under the road. Okay, the last two are installed under the road. Okay, but loop detection works similar to the tube. When the car passes over the detector is very close to the road actually. Okay, so almost on the surface of the road. Okay, but obviously it's leveled, so you don't feel it. But it is when the car passes, it actually senses, okay, tires have passed, and it will take the count, and it can also do the speed analysis for you. It does. Okay, we have it on the signals here. And then we have the vibration detectors. They are further under the surface of the road, and when the car passes or the vehicle passes, it creates a little bit of vibration. Okay, like they measure the vibration for earthquakes. So they are similar in nature, these detectors. So the vibration obviously is very low. You may feel it on bridges. If you have stood on a bridge, okay, when the traffic was passing on the side of the bridge, you can feel it. Even on pedestrian bridges, you can feel the vibration. But on ground, roads at grade, you cannot feel the vibration, but there is a vibration. Okay, so these detectors will catch the vibration and they will count the vibration actually. Okay, and then we have the technology which is called as VIP. So VIP stands for what? Tell me. What is the meaning of VIP? Yes, VIP means what? You should know that. All of you behave like VIPs, right? So VIP means what? Tell me. Very important person. Yes. Okay. So, but in this case, in case of traffic, there is no important person. Nobody is important except me. Okay. So here it means video image processing. Here VIP means video image processing. Okay. So video image processing is the entire system. So you need a video. Video comes from where? Camera. Okay. Then you need to store the video. Okay. You need to store the video. So you need some storing device as well. Once the video is stored, you need to process the video. Okay. So you need some processing software as well. So the software will look into the video and you will see, okay, how many vehicles, what is the speed of the vehicle, and so on. Okay, so it will do the processing, and then the software will give you the data in the form of numbers. Okay, so what the camera is getting is the video, then it stores it, then it goes to a software or a processor which will process the video, and then it will give you the answers, the results in the form of numbers like we want. So this whole process is called as video image processing. Okay, how does it work? You need to calibrate the camera. This is the most important item in this. Yes, developing the software as well, but now with the help of AI, anybody can do the coding. Okay, but the important thing is calibrating the camera. Okay, what does it mean? Or calibrating the software of the camera. What does it mean? You need to uh, uh, to you need to identify the vehicles which are in the video. How would the software know that this particular uh, size of the object is a vehicle, and if it is of this much size, then it's a pedestrian? How will the software know? Okay, so you have to train the software, you have to calibrate it. Okay, so you will do some trial runs in which the software will detect different images, and then you will classify it. When you detect this size of the object, put it as a car. When you detect this size, put it as a truck, and so on and so forth. Another important thing for calibration is the background. Okay, so we can have a black color car, and we know the asphalt pavement is also black color, and we know we can have a gray color car, and we can have the light pole which is also gray color. Okay, so this is another sort of calibration. Another thing which is important for videos and cameras is lighting. Okay, so if you have seen any recording, or when you are taking your own pictures, you will see there's a lot of effect of lighting on it. Okay, so when you are doing it one time, there's no problem, right? You can adjust the light and so on and so forth. But this system will work in the real field, and the real field 24/7 for the whole year. Okay, so the lighting conditions will change a lot. It may go from very bright to very dark. Okay, and something in between as well. So you need to calibrate the camera for different lighting conditions as well. You need to calibrate the software for different lighting conditions as well. Okay, so the black at night and the black in the day, they are not the same for the image, for the video. Okay, so the main item here is you need to take a lot of care in calibrating the software with this system. Once you have done the calibration properly, it can give you a lot of data, and it can help you even control the whole traffic system as well, because you have the full picture now. Okay, so it can give you how long is the queue, what is the speed of the vehicle, what is the count of the vehicle, and the count can be classified how many cars, buses, trucks, and bikes, if you do the calibration correctly. Okay, so you can get a lot of data, and once you have it, you can see the link of the video is there. This system can be attached to signals, can be attached to information systems, message signs on the road. Okay, so according to the traffic condition, you can inform the driver what is going to happen or what they will face, or you can change the signal timing or change the speed limit. Okay, so this whole thing can be done with the system. So we have done some examples for the axles, converting the axles to vehicles, for the counting, for the speed studies. So you can have a look at these examples and these in your books. Okay, the two books, collecting traffic data and analyzing traffic data. Okay, so the word spot means that the study has to be over a spot. Spot means a point. So by default, spot speed studies. Now keep in mind, I'm saying spot speed studies. Okay, so there are other speed studies as well which are not spot. So you need to keep it in mind. So now we are especially discussing spot speed studies. So a spot means a point. So by default, you need a speed measuring radar to do these studies. Okay, but they know that everybody may not have the sensor and the device and the radar. Okay, so doing spots, and they may still need to do spot speed studies. There are a lot of applications of spot speed studies. We will discuss them now. So I want the spot speed data, but I don't have the device. Okay, so what to do in that case? They say yes. Okay, if you take a short distance, that can also be considered as a spot. Okay, if you take a short distance, that can also be considered as a spot. So they gave me a limit. If your distance is less than 300 meters or 1000 feet, it can still be considered as a spot. But this is the extreme limit. So you don't have to go till the limit. Okay, you try to keep them short. Okay, the minimum, which is not written here, is the length of a normal car, or it should be more than the length of a normal car. Okay, so minimum should be more than the length of vehicle, I would say. Okay, your vehicle, normally we do it for a car, so vehicle is a car. Okay, so the maximum is written here, but the minimum is like the car itself is I don't know, say 3 meters or something. Okay, or 6 meters or something. So you cannot like have a distance which is less than 6 meters, because even the car will pass it and you will not have the time even to use a stopwatch. Okay, so but at the same point, you don't have to go to the extreme. Don't go near 1,000 feet. Keep it as less as possible, because eventually what we are looking for is a spot. What we are looking for is a spot. This is just like a compromise. Okay, yeah, I don't have the, I cannot do it exactly over a spot. Okay, up to this distance allowed. Okay, why do we do spot speed studies? Spot speed studies are done to find out the choice of driver regarding the speed on the road. What speed the drivers want to drive on the road. Okay, the drivers want to drive on the road. Okay, and this can only happen when you have free flow conditions. Okay, now we have talked about free flow conditions and free flow speed earlier as well. What do we mean by free flow? Tell me. The flow is free, right? On the highway, nobody is asking me to pay something. So what do we mean by free flow? Yes, free flow means what? What is the meaning of free flow? Tell me. There is no intersection, only this. This is for uninterrupted, not free flow. We may not have free flow without the intersection as well. We not have free flow without the intersection as well. So facilities without the intersection may not have free flow. Free flow is something else. What do we mean by it? No congestion. Okay. They're not stopped by any signal. So you are saying the same thing. Okay. So okay, let's clarify this. Free flow and uninterrupted. What you are saying, no signal and no intersection. Okay, that is, yes, vehicles move without any restrictions. That is free flow. No congestion is free flow, but no traffic signal and no intersection is uninterrupted. Uninterrupted. Okay, so uninterrupted facility may have free flow or it may not have free flow. Free flow is a type of condition. Uninterrupted is the type of facility, type of road. So these are two different things. Okay, any type of road can have free flow. Interrupted, uninterrupted, without intersection, with intersection. Okay, so these are two different things. Keep it in mind. So what you are saying, you are not restricted by other drivers. Free flow means you are not restricted by other drivers. Okay, so you are driving according to your choice and the road environment, road design. Okay, so now we come to the second condition of spot speed studies. The first condition was the distance. Ideally, distance should be 0, if not less than 1000 feet. Now, second thing, we want free flow conditions. So free flow conditions need the traffic to be low. Okay, how much is low? They again give me a value. Okay, somebody may say, okay, 2000 is very low. Somebody may say 500 is very low. Somebody may say, no, more than 100 is very high. Okay, so the limit should be 100. So they gave me the value as well. Okay, so in most of the cases, between 750 to 1000 is considered low enough to do spot speed studies. So these are again extreme values. Lower is better. In that case of distance as well as volume, lower is better. Okay, but if you have to account the volume, then you should not go more than these values. Okay, the volume should not be more than these values. Now you have seen that running out of battery. Just give me 1 second to put it on charge. Just one, like couple of seconds. Okay, so going back to the point, when you are doing a spot speed studies, there are two restrictions on you. Ideally, should be over a point, distance 0. But if you don't have a device which can do it for you, then you can go, or you should keep the distance less than 1000 feet or 300 meters. In terms of volume, you should not do it more than 1000 vehicles in any case. Okay, and this is for major roads. For minor roads, because minor roads are narrower, their design is much lower, so you should not go more than 500 in that case. Okay, so you have to decide according to the type of road you have. But the point is, I'm looking for a speed of the vehicle over a point, as close to a point as possible, and as free conditions as possible. So driver should have a free choice. Okay, so if you feel that in this condition, without counting, okay, I can see the drivers are going, or they have too much distance between them, they are just going according to their own choice, this is enough. Okay, like you don't have to do actually account every time. Okay, but you can have an indication when you see the spacing between the drivers. Okay, why do we do spot speed studies? Remember, spot speed studies are done for finding out the driver choice. So as engineers, where the choice of the driver is important for us. First thing is for speed limit regulations. Maybe I mentioned it, I believe I mentioned it earlier as well. When you are setting up the speed limits, it should be according to the choice, or sorry, according to the expectation of the driver. The driver is driving on a highway which has 4 lanes, it has very wide median, it has very wide shoulder, there is no obstruction, the road is straight. He is expecting to go at high speed. So your speed limit will not be effective if you are not fulfilling the expectation. The most of the drivers will go over it. Okay, and you have like some of the blame from it. Yes, the driver should follow, but you are going against the expectation of the driver. So how to know the expectation of the driver? You do spot speed studies. Then for design of the road. Okay, so I want to design a signal, I want to design turning a curve, okay, on the road, I want to increase a lane. So for all these applications, I will use spot speed data. Okay, remember we are talking about free flow conditions, so the speed will be higher. So I'm looking for the worst case in that sense. Okay, so spot speed will give you the critical scenario, the worst case, or close to the worst case. We don't always go for the worst case, but so you can see some applications are written here where the spot speed data is used. Okay, then we have again the example of signal I gave is part of the design, right? It's part of the design of the road. So later on, when if we get to the design of the signals, you will see we'll be using speed there, and that speed, just keep it in mind, will be the spot speed study, will be the spot speed. High accident locations. If you feel at a particular location the accidents are very high, a spot speed study is 99% of the times part of the investigation. Why the accidents are higher? Okay, in Bahrain, in Saudi, and maybe I forgot now, maybe in Abu Dhabi as well, we analyzed the data. We found that the most common reason, or among the most common reason, is overspeeding. Bahrain, I'm sure about it. Saudi, the data which I have seen for few cities, I'm sure about it. Abu Dhabi, I'm not sure, but overspeeding is one of the most common reasons. If not the most common reason, it's one of the most common reasons, maybe in the top 3 in all the cases. Okay, so you would know about it when you do the spot speed study at that location. Okay, you know the drivers are overspeeding. Okay, so without that you cannot know. Okay, before we go into the analysis, I would like to present some of the definitions, the terms which we are going to use later on. The first one is average or mean. Now you know that, right? Average or mean. In that case, in the case of spot speed study, we will be calling it mean speed. not average speed. Okay, not average speed. Okay, let me ask you a question. If I do sum upon n, is it an average or a mean? This this thing what we do, most of you do it, right? So is this an average or a mean? What do we call it? It's a mean? Sure? No. Okay. So yeah, no, it's considered an average. This thing what we do normally is considered an average. Mean could be the same or mean could be something different. Okay. So in the earlier topics we have done space mean study, time mean study. Okay. If you go to those equations, okay, one of those equations has a speed upon n, the same which I did here. So in that case, average is same as the mean. But there are other cases in which the average is not the same as mean. So for mean we do something else, which is what you will see in this topic now. Okay, so I will bring a new equation for calculating the middle value, and we'll call it mean, not average. Okay, because these are different things. But you know the concept. Okay, it's basically something in the middle of the data. Then we have a standard deviation. Standard deviation simply means the average difference between the mean and the other values. Okay, so you have a mean x, and then you have values x1, x2, x3, x4, up to whatever. So if you take the mean, the difference between the mean and x1, and then mean and x2, and mean and x3, and so on and so forth. So you will have like 100 values. If you take the mean of those differences, that will give you an indication of standard deviation. And keep in mind, this is just for the sake of explanation. Okay, standard deviation has an equation, but the concept behind that equation is what is the average difference between the mean and the values. Okay. 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 Then we have 85th percentile speed. Percentile means the highest value for a range of data. Percentile means the highest value for the range of data. So 85th percentile means highest value for 85% of the data. If I say 60th percentile, 60, that means highest value for 60% of the data. Okay, so if I tell you 85th percentile is 30 miles per hour, so 85% of data is under 30 miles per hour. Okay, so it gives you an upper limit. The percentile gives an upper limit. Okay, so whatever the value is, you can consider the percentage of the data under that limit. Okay, so 85th percentile of the data, and why it is important, we will talk about it. Okay, median, you know, right? Median, the middle value, exact middle. Okay, you will have like 50% value here, 50% value there, exact middle. Then you have the pace. So pace is not a value, it's a 10 mile per hour range. It's a 10 mile per hour range. Which 10 mile per hour range? The range in which the percentage of drivers are more than any other equal range. Okay, let me give you a very simple example. They are not the same thing, I already explained the mean and the average. Okay, they can be same, but they can be different as well. This is according to statisticians. Okay, the pace, for example, I have 10 to 20 miles per hour speed, and I have 30% drivers in them. I have 11 to 21 miles per hour, and I have 25% drivers in them. 25% drivers are driving in this 11 to 21. And I have 12 to 22 miles per hour, and I have 40 is possible or not? Possible, right? 40% drivers in them. 40, 30 is 70, and yes, okay. And then I have 13 to 23 miles per hour, and I have the remaining 5% drivers in them. Okay, so which one is the pace? Pace is this one. Okay, the 12 to 22, that's the pace, the one which had the highest percentage of drivers. Okay, so pace is a range which has highest percentage of drivers compared to any range of similar interval. Okay, so the interval of the pace is 10 miles per hour, as I showed you in the example as well. Okay, so the number of drivers in the pace 10 mile per hour range will be more than any other 10 mile per hour range in the data. Okay, any questions up to now? Is this clear? The idea of pace is clear? Okay, now we move on to data collection, and then we will move to data analysis as well. So we are looking for a spot speed. You can do it using a permanent counter. The permanent counter, which is specialized for speed studies, is called a loop detector. They have installed it near many signals because signal yellow timing can change according to your speed. Okay, but it doesn't mean you can start coming at 200 kilometers per hour. The signal timing will change. No. Okay, it has a limit. It may change like fraction of a second for you if you are too fast, but not more than that. Okay, so loop detectors are permanent detectors. They are installed under the road, and their main function is collection of speed. I believe I have a picture here. Yes. So this is a loop detector. Okay, and this is where the speed is calculated. So the car passes from the first part of the loop and it reaches the second part of the loop. The timing is calculated, the distance is known, and you have the speed here. Okay, the distance means the distance between the two ends of the loop, and the timing is what you are taking. Okay, so a permanent detector for speed studies is a loop detector. We had talked about other permanent detectors earlier and other instruments earlier. They are not basically for speed. They can do speed, but the specialized equipment for speed is this one, permanent one. And then we have the portable ones, like a speed radar, a speed gun, okay, and so on and so forth. And some of them are used by hand. Okay, so if I'm using a speed radar by hand, then that will be a manual method, right? Because I still need to press the button and hold the radar or hold the gun to get the data. So that will become a manual method. Okay. So here you see semi-automated and automated and manual methods as well. Or you can do it using a stopwatch, as we have explained earlier. Okay. Now the data which you will get from will be the speed values, right? So if you take data for 500 vehicles, you will have 500 speed values. Now for the purpose of analysis, we don't keep the data as individual values. We keep them in groups. Once you collect spot speed data, we form groups of this data. Okay, and we call them speed groups. Okay, so how to form the groups? You can see it over here. Okay, it's not clear. Can I zoom in? Yes, I can. Okay, it's a good thing. So the actual data was values. Then I said, okay, I will divide this data into 2 mile per hour groups, starting from 30 going up to 62. So 2 mile per hour groups. Okay, keep in mind the groups must be same size. All groups must be same size. So where are your observations? You made the groups. Where are the observations? Observations are here. Now here what you see is what is telemarks. We call them telemarks. Lines. I told you about this earlier as well for counting. Okay, telemarks, each line means one count. Okay, so if you see 4 lines here, that means 4 vehicles. Then you see an inclined line means 5 vehicles. So each inclined line means 5 vehicles, because I'm putting 4 straight lines, and then if there's fifth one, I'm putting as inclined. So there's 5 here, there's 5 here, there's 5 here plus 2, so 7. So counting becomes easier. So this is what we do. This is how telemarks are arranged. 4 inclined, then 4 straight, 1 inclined. So each incline means a set of 5. Okay, so now basically the data which you have is, I have above 32 till 34. You can see greater than sign here. Above 32 till 34, 5 vehicles. Okay, above 30 to 32, no vehicles. Okay, now these 5 vehicles above 32 to 34, maybe one of them has a speed of 34, another one has a speed of 32.5, so on and so forth. So individual values are gone, but for your project you will give me the individual values in the report as well. Okay, keep it in mind. For the project report I need the individual values and then the grouping as well. Okay, so we are doing the grouping. So some rules you need to keep in mind when you are making the groups. Okay, typical width of the group, typical size of the group is 2 miles per hour. Typical. Okay, recommended. It can be more, it can be less. More than 5 miles per hour is not recommended at all. So maximum is 5. Recommended is 2, maximum is 5. Okay, minimum depends upon number of values you have and the distribution of the speed. Okay, so if you make a group which is too big, okay, so you made a group of 4 miles per hour. Now all your values fit into one group. So 32 to 34, or 32 to 36, all values are in this group. So that means you did not distribute the data properly. You should make a smaller group so you can have more groups. Okay, so 1 group, 2 group, 3 groups, these are considered very small number. Okay, so ideally you want more than 3 groups at least. Okay, so you divide the groups into you make the groups so that you can at least have more than 3 groups. Okay, and if you make 2 small groups, okay, so if somebody said, okay, I will make a group from 32 32.1, then 32.1 to 32.2, these groups are very small. What will happen? Most of the groups have 0 values. Okay, because your interval is very small. So avoid having 2 big groups, the groups which are too large, because the total number of groups will be too small then. And avoid having groups which are too small, so that you avoid 0 values in most of the groups. Okay, so these are some of the guidelines, and next time we will start with the calculations. Okay, I'll start showing the data and so on and so forth. So just give me a second. I think I can just take your names from this list. Okay, so I don't want to bother you. Just stay here till I just take the attendance with myself, and then you can leave. Okay, so Aisha is here, Bayan, Fatma Abdullah is here, Fatma Hussain is here, Hafra Juma is here, Hissa is here. Okay, Mariam Musa is here. Mariam Musa is here. Okay, Mariam Ahmad is here. Yes, Mariam Musa is here. Natha Shaki is here. Tahara Jafar, Zainab Jafar. Okay, thank you. Nobody is absent. Good. Okay, see you next time, inshallah.